हेलो फ्रेंड्स, वेलकम टू आवर चैनल द वे टूवर्ड्स केमिस्ट्री। आज हम दो क्वेश्चन का नोट्स शेयर करने वाले हैं, जिसमें फर्स्ट क्वेश्चन है, मेंशन द लिमिटेशन ऑफ क्रिस्टल फील्ड थ्योरी एंड सपोर्ट इट विथ एटलीस्ट 2 एक्सपेरिमेंटल एविडेंस। और सेकेंड क्वेश्चन है, ड्रॉ एंड एक्सप्लेन द मोलिकुलर ऑर्बिटल एनर्जी लेवल डायग्राम फॉर COF6 3-। देखते हैं। Limitation of CFT. Crystal field theory is highly useful and more significant as compared to the valency bond theory (VBT). Even after such useful property, it has many limitations. The following points will be clearly state the limitation of CFT. A. First point. Crystal field theory assumed that फर्स्ट लिमिटेशन ये है, क्रिस्टल फील्ड थ्योरी assumes that the bond between metal and ligand is purely electrostatic, that is interaction between metal and ligand can said to be very realistic. Thus CFT fails to explain the covalent character between metal and ligand in complex, which is observed in electron spin resonance (ESR) and nuclear magnetic resonance (NMR). For example, in the ESR spectrum of IrCl62- ion, hyperfine splitting is observed. Thus, this indicates the delocalization of d electron among the 6 Cl- ion. Also, the unusually larger absorption band intensity is observed for the tetrahedral complex like COCl4 2- is due to appreciably covalent character between metal and ligand, which is not explained by crystal field theory. Second limitation. CFT was unable to explain the possibility of existence of pi bonding in complex. That is, it gives no idea about the metal ligand pi bonding. Third, this theory only considers the d orbital of central metal atom and hence no consideration for the rest of the metal orbital like s or p orbital, etc., and also ignore the pi orbital of the ligand. Hence, it does not explain the pi bonding in complex. Fourth limitation. This theory fails to explain the behavior of certain metal which causes larger splitting while others shows small splitting. That is, CFT unable to explain the amount of splitting in different metal atom or ion. Fifth limitation. It unable to explain the behavior of ligand, that is, which ligand behaves as strong field ligand and which are behaves as weak field ligand. That is, it fails to explain the electrochemical series. For example, in complex, the ligand H2O behaves strong ligand or strong field ligand then OH-, that is, it fails to explain why H2O present at right side of spectrochemical series and OH- at left or halogen are at the last of spectrochemical series. Experimental evidence of those limitation or in support of those limitation. All the limitation of crystal field theory have the experimental support. The two evidences in support of limitation are I मतलब पहला Landage splitting factor. Landage splitting factor is denoted by G. It is usually used to predict the magnetic moment of transition element or transition metal complex. The formula that used to predict the magnetic moment is mu equal to G into root over J into J plus 1, where mu is magnetic moment, G is Landage splitting factor and J is total angular momentum. It helps to determine the delocalization of d electron. The value of G is determined experimentally, which shows that d electrons are always delocalized into the ligand orbital. This can happen only if there is a concept of covalent bonding. Hence, the value of G determine or indicated the covalent bonding in the metal and ligand bond. मतलब ML bond. Second, nephelogitive effect. The inter-electronic repulsion between partially filled d orbital of metal and ligand orbital in electron gives rise to a number of energy level which can be expressed in terms of inter-electronic repulsion parameter called Rake parameter B plus C. It has been observed that the value of Rake parameter is always decreases on the complex of metal ion formed. मतलब when complex of metal ion is formed, the value of Rake parameter became lower, which indicates that the repulsion decreases due to the delocalization of electron density among the ligand orbital. Normally, value of electronic repulsion decreases in complex, thus the value of beta is less in complexes than the free ion. The reduction of beta from its free ion is normally reported in terms of nephelogitive effect. Beta equal to beta dash complex divided by beta free ion. Beta nephelogitive effect parameter, which refers to the electronic cloud expression. The nephelogetic series F minus greater than H2O, then NH3, En ethylene diamine, NCS minus, Cl minus, Cn minus, Br minus. Thus, this effect shows that more covalent the Ml bond, more is the unpaired electron of the metal are spread out over the ligand, and lower is its energy required to spin pair these electrons. Then next question. Draw and explain the molecular orbital energy level diagram for CoF6 3-. Here CoF6 3- is an octahedral complex where the central metal is CO3+ and ligand are 6F- fluoride ion. According to MOT, a complex CoF6 3- is formed by the combination of the atomic orbital of CO3+ ion and the ligand group orbital of 6F- ion. The ligand group orbital LGOs are the group of orbital formed by the symmetry adopted linear combination of lone pair orbital of 6 ligand F- sigma orbitals. 6 ligand sigma orbitals and 6 LGOs have the same symmetry as 6 AOs of the CO3+ ion. In octahedral complex, only 6 AOs of metal participate in complex formation due to the fact that the central metal cation CO3+ ion have 9 valence shell or atomic orbital. Those are 4s for px, for py, for pz, 3dxy, 3dyz, 3dzx, 3dz square, 3dx square minus y square, etc. Since in an octahedral complex the ligand are approaches from axis, and hence only 6 suitable AOs participate in molecular orbital formation and forms 6 BMOs bonding molecular orbital with 6 ligand group orbital with 6 ABMOs antibonding molecular orbitals, whereas the other 3 AOs remain as non-bonding orbitals, that is dxy, dyz, dzx. These are remain as non-bonding, and 4s for px, for py, for pz, 3dx square minus y square, 3dz square are participate in complex formation. For an octahedral complex Ml6, the metal s orbital have a1g symmetry, metal p orbital have t1u symmetry, and d orbital have eg and t2g symmetry. ऑर्बिटल एंड सिमेट्री। उसके बाद है और जी क्या है, जी जीरेड और सिमेट्रिक, और यू अनजीरेड एसिमेट्रिक. Again, before overlapping with edge of metal ion, the 6 ligand forms 6th ligand group orbital by symmetry adopted linear combination, and thus they have same symmetry as the symmetry of edge of central metal ion. Among the 6 LGO in octahedral geometry have A1G, T1U, EG symmetry. The A1G LGO of ligand interact with A1G of metal edge atomic orbitals form bonding A1G and anti-bonding A1G star. The T1U LGO of ligand interact with the T1U of metal orbital and form bonding T1U and anti-bonding T1U star. Similarly, EG symmetry of LGO combines with EG of metal orbital and form bonding EG and anti-bonding EG star. The T1G orbital of metal present as non-bonding. The separation between EG and T2G is del O as in CFT and it depend upon the field strength of ligand. तो इसके बाद है let us draw the MO energy level diagram for CoF6 3 minus. In CoF6 3 minus, the central metal ion is CO and its oxidation state is +3 and ligand are 6F minus. These are weak field ligand. We know that in case of weak field ligand, the gaps between EG and T2G decreases. Thus, pairing energy is more than del O. So, in this case, no pairing takes place in T2G. In CFC 3 minus, C plus 3 have D6 configuration and 6F minus donate 12 electron, thus total electron equal to 18. CO36 का इलेक्ट्रॉनिक कन्फिगरेशन क्या है, फॉर 6 लिगेंड टोटल इलेक्ट्रॉन कितना वो लोग डोनेट कर सकते हैं, 12 इलेक्ट्रॉन. द फिलिंग ऑफ इलेक्ट्रॉन इन द मोलिकुलर ऑर्बिटल एनर्जी लेवल डायग्राम occur as follows in COF6 3 माइनस. मतलब ये है मोलिकुलर ऑर्बिटल डायग्राम. करेक्टरिस्टिक्स क्या क्या है CF6 3 माइनस का, इसमें अनपेयर्ड इलेक्ट्रॉन है तो इट इज पैरामैग्नेटिक, अनपेयर्ड इलेक्ट्रॉन 4 है तो इसका स्पिन मल्टीप्लिसिटी 5. 2s + 1 स्पिन मल्टीप्लिसिटी कैलकुलेट करने के लिए फॉर्मूला. थैंक यू.